today we are here to start another live coding session together. So we want to start another project. Basically, we want to implement an interface for a WitMotion IMU sensor. This kind of IMU that you can see in the image has both the IMU, the inertial sensors, and also GPS. So you can easily connect a GPS antenna to that and then start collecting GPS data also. So basically what we want to do is to implement a library, an interface to communicate with this sensor and easily acquire data. Of course, I'm gonna share the repo in the description, and those who want to contribute to this repo, feel free to send a request and they can be added as a contributor and start contributing to the repo. One of the things that pursued me to do this is that the WitMotion company, the SDK that they provide is not really what I expect, and I think we can do something better, depend on the project that we want to do, and we use this inside that project. So I'm going to create a more well-structured code, a C++ code, because they provide a C code for the library for the sensor, but we want to implement a C++ code from scratch, and also maybe later I add a Python wrapper for this library just to be to help those who want to use this kind of sensor in C++ or Python can use it easily. And also so the basically this let's say this live coding, in this live coding we want to implement a kind of the acquisition part of the library, and later if I want to implement the part regarding the commanding and calibrating the sensor, we're gonna record that, and also I'm gonna share that with you guys. So basically this is all for now, and if you want to buy the sensor, I'm gonna share the link for buying the sensor, and also you would need a TTL to USB converter for connecting this sensor to your computer or your embedded system if you want to use a USB port. So feel free to use these links to buy these products. Of course, I don't get any benefit from WitMotion or the other product that I'm gonna add. It's just these links just for you to be able to start up this project if you want to do it as fast as you can and be more aligned with what we want to do. So let's do that. So the first step is it's better usually when you do a project, it's better you actually start planning the project and at least have some abstract design in your mind, how to follow, what components you would need and what you want to do during your coding, because it makes your mind more organized, and you would do less mistakes and you need to do less re-implementation. Of course, for those of you who have experience in coding, sometimes you just start a project by coding something, and in middle of the code, or the worst case scenario at the end of your coding, you understand, okay, I would do it better if I do something like that. So you end up re-implementing like most part of your code. So it's better you start at least figuring out what you want to do. Of course, during time when you have more experience, and if you do a certain type of projects more frequently, you can actually predict some of these obstacles or maybe bumps before starting the implementation, and you would need to spend less time in implementing the code or fixing bugs. So basically, what we want to do is that we want to implement an interface for the sensor. So we have a host operating system which provide initial features for us, including recognizing the device and managing the I/O to that port and all of that. So for this specific project, we're gonna use a normal Linux, in my case an Ubuntu, and then we would have a component, we call it, let's say, serial interface, that actually communicate with that USB port and start reading and writing data. So basically this layer provide initial features for us to read and write, open the channel and close the channel for that USB port. And the last one is, okay, I'm receiving the data, but how do I decode it? Because these sensors usually pack the data in some sort of format, so you need to unpack it. So in this part, we just implement the code to unpack the data in a way that is more understandable for us, and we can use it in our inference or in collecting data in whatever we want to do. And for the library itself, so as I mentioned, we will have an IMU sensor, like a serial interface. That would be our first component here. There is something here that I don't know why I didn't remove it, but anyway, you understand it. And then we have a decoder that we pass the data to this decoder to decide, okay, what kind of data it is and how I can decode it. And after that, in this library, we actually register for a listener. You can also, like maybe later, or if you want to fork this repo, you can add this feature to, like, add multiple listeners or do something like that, or even transmit it through your local network or whatever you want. So we provide this feature that a user can add the listener to get these to subscribe to the system and receive the latest received data from the IMU. Okay, very well. So now we want to start our project. So basically, the first thing that we said, now I realized I say basically a lot. Please let me know if I say basically one more time. So the first component that we want to implement is the serial interface. So how we connect to USB, to opening the channel, closing the channel, reading from the channel, and writing to the channel. Of course, for this series, we don't do anything related to the writing, like data writing, or doing like for commanding or calibrating the sensor, but we put it there. We will put it there, and then we will decide what we're gonna do later, if we want to actually add that, or if one of you decided to add yourself as a contributor, and then maybe we can add that then, and then we just do a code review. So let's do the serial. So now, as we did before, I just add one folder, include, and then one folder source, standard practice, and then we add the actual, we add the serial. Perfect. And now we again start defining the header and all of that, just to make sure that we have everything under control. Great. Now let's start implementing. So you going to understand why I did that, but I'm just adding the thing. So we have a file handler. Basically in Linux, every device driver gonna be recognized by OS, like presented as a file or something similar to a file. So we gonna, and when you connect, you will have a descriptor that describe, okay, what file and with what access you actually open the channel for. So, and it's an integer. I'm just going to define a type for that, and then we need to also, one of the important thing when you connect the TTL port, so you need the address and you need the sampling rate. Okay, so you need to define these two in order to be successfully connecting and receiving correctly the data. And for that, I'm gonna define another custom type, and for this project I'm going to define a namespace. So basically you are going to define this. Why I did that? Okay, and then you start implementing the class, handling everything. Perfect. And as you know, I prefer to define my class fields at the beginning of the class. So what we need, this is why we added the string header. What you need is first the path to your device driver, like device file, which in Linux would be /dev/something. For example, in this case would be /dev/ like tty usb 0. And we need this one, and also when we open we would need perfect. Okay, so after that we would need well, I want to actually use a builder. So what it would be like is that I make my constructor a private, and then I introduce a static method for building the instance from this object. It's because I want to do few, like run a script before actually providing the instance to the user or the code that gonna use this class. So I'm going to define my constructor as private, and I'm going to pass the device, the path, and then also this one. So I'm defining the signature, and I don't need anything. I don't need to determine the argument names here. And while you do that, you need to delete the default constructor. So basically you need to determine that, okay, I need to delete this, yeah. And of course you would need to define the destructor to release any resource that you are using, and like finalizing everything before releasing the memory that holding that object. And I'm going to define some set getter for the parameters that I need to actually be able to do that. And for doing that, you can make it const and then define. So I don't need to define this method inside my source code because it's just one line code, so why bother? And also I'm going to, sorry, perfect. No. Yeah, I prefer to do this like that. So two things. First, here also I define it as const. Later, what I want to show you is that, so in C++, in C++ 17 or upper, you have a flag that you can add to your code that is descriptive actually. So what does it mean? It doesn't influence how the compiler or linker actually look at your code, but it can help users or others that use your code or want to or maybe review it to understand that this method output is important and should not be ignored. It's very important, and it makes your code more transparent and more readable. And also some of the compilers are gonna actually raise a warning if the user don't assign this the output of your method to any variable, something like that. And you can use that by using no discard flag. So I'm adding that, and also I'm defining few method. So begin, of course, end, to end the channel or close the channel, receive, which would basically would be a uint, how can I say? So you will determine the buffer that this method needs to or move the data that it received to that buffer, and also the size of this buffer, something like that. Well, it doesn't matter if you define the name of the argument here or not. And also one for sending data. Of course, we won't use it for now, but you can use it later. Perfect. It's better you save your code regularly because there are a lot of stupid things can happen that if you don't save it, you suddenly lose a lot of code. And yeah, but of course, new IDEs prevent a lot of these, but why risk it? And you, I'm also gonna implement a normal is open thingy. Yeah, perfect. Great. And for this one also, I'm going to add the no discard just to let the others know that, okay, the output is the most important thing that this function is doing. And for the last method, I'm going to define the build function that I mentioned, which would be a static method. So it will be in static. It return a pointer, and it just receive something like that. And also Yeah, it's better you be consistent in your class method signatures. If you don't name the arguments like arguments, don't do it for all of them, not like this. And also, just for make our code easier, I'm going to define also another custom type for this serial class that we define, but for its pointer, and we call it, let's say, for example, something like that. And that's it. Now let's do another one. We go to source folder and we are going to implement the source code for our serial class. Let's write it. Okay, so the first thing is, of course, including the serial header, and include a few other things. So we want to include the file system header, and also we are going to include the IO stream for seeing, see out, this kind of thing. And we are going to include what else? Yeah. Perfect. Yeah. Also, for like, because it's like a low-level code, so we may need some of the C-string functions, and the most important one is the term iOS.h that actually provide us the feature to communicate with the device driver for our USB port, and changing the attributes and all of that. So it's very important to add this header file also. And if we need other header files, we're gonna include it later. As we did previously, I just split my screen to have a better view of what we already implemented. So let's implement the first one, the build one. Yeah. So we are going to provide the function or class method definition here. Perfect. And string, and also great. Let me make it smaller for us to see. You can make it multiple line, but I'm going to do that. So it actually built an instance of a serial class. Yeah. And validate the given arguments. Now that we write this, so we first check, since it's the baud rate is unsigned integer, we wouldn't worry about the negative values, and we just need to check if it's 0 and if the file system that we're gonna use, the device driver that we're gonna use, is actually exists. Perfect. So we check if any of these things were not valid, we just return it, and then return. It's a good design pattern that you use because, oh, I'm gonna actually record another live coding session. It's just for explaining different design patterns in C++ and in Python in separate shows. So it would be nice if you guys subscribe my channel just to be updated about the episode that I'm gonna publish, and also it going to motivate me more to record more videos if you like the contents. So the next one I'm going to do is, of course, the constructor. Perfect. The constructor, the private one, had, yeah, and also perfect. So basically it's very easy. We don't want to, it's easier to implement a lot of this or use some of the features in C++ to make your code simpler and smaller. So I did that, and then we just do an empty body. We could do that in the header file. I just did it here, it doesn't matter. So you can do it also in your header file because it's just some initialization. And for the other, for the deconstructor part, I'm going to check if the file, yeah, is, yeah, let me see, sorry, def handler. Okay, I just check because if we have a valid def handler, we know that the begin method is started already, so I'm going to end it or close the session. The next one that I'm going to implement is actually the begin function. Yeah, so the begin function didn't have any arguments, so I'm going to do that. The begin function has a lot of compared to the other one, has a lot of coding, so bear with me. So firstly, we open the a channel to our device file. So I'm passing the dev file, but since open is not a C++ code, I have to pass the string as a C string. So there's a function in a string, the std string. I'm going to use that. So I'm going to let it know to, okay, it's read, not read only. One of the problem of using the autofill features is that sometimes you just accept it and then you have a problem down the road. Then we gonna check if the file that is already passed to this one is actually a terminal. And perfect. So we are using the is attribute thingy, the method from this header. So if this one is, for now we don't log it, we just show it in the we just show it inside our console. Yeah. Okay. We go to the next line. We are going to handle this later, how we, okay, if this happened, what we should do. For now, it's okay, because when we want to test it, we just pass something that we are sure that it's a device, but it's better you handle it properly. Great. So now I want to actually retrieve the features and the attributes of the device file that I just opened. So for that, I'm going to instantiate two variables, and use the old one to retrieve it, and use the new one for setting the attributes that I want. I'm going to use tcGetAttribute to get all the features and attributes of that terminal or whatever device file that you open. And then I want to make sure that retrieving those were successful. So if this one returned anything except 0, it means that it wasn't successful enough. So I'm going to write error message. It seems that I don't believe in double quotation anymore. Perfect. Let's say yeah. Why did I do that? It is better. Later we can add different things, and then if this happens, it doesn't mean anything to go through the rest of the code. So now for actually setting the new attributes and features for the device file, we need to first initialize the structure by making every field 0. So let's do that. So it actually receive a pointer and the size of that memory block, and set all the bytes 0. It's very easy and straightforward thing to do, and that's it. Perfect. Now let's start adding setting the how can I say, setting the attributes that we want. So the first thing is to set the C flag. Perfect. And also we want to read it, and let's do CS8 also to show that it's a byte thingy, and and what else? Oh, yeah. Perfect. Yeah. And why this one? Oh, why did I do that? I don't know why did I do that. I forgot to mention the name of that, the structure type that we want to actually use. That's why it was giving me some problem. Now, let's set the sampling rate. So now we say, okay, for different values, what we're gonna do. So for example, in case of sampling rate of 2400 bit per second, I'm going to set the input speed to and we use this flag. We have to do the same thing for the output speed. So you need to do that, and then you add the break just to make sure that your cases don't run like consecutively all together. Perfect. And for this one, 4800. Yeah. And for the next one, 9600. Again, 9600. The next one would be 5200. Yeah. 5200. For the next one would be 230, and looking at my notes just to make sure I don't make any mistakes. We do the same thing for all of our selected bandwidths. So we decide what bandwidth we're gonna support, and it's really up to the fact that whether our sensor also support it or not. So you need to consider that also. Yeah. For the 6. Great. Also, we need to add the default case to make sure we have a policy in case if the user or third-party code just give us some unsupported like some unsupported thing option for the sampling rate. So I'm going to, if anything else, I'm going to do the 96. Yeah, 9600. That's the best thing. What else? The other thing that we are going to do is that I'm looking at the options that I need to add, because you need to go through the sensor documentation and and also some of the other configurations, just to make sure that you don't make mistakes, because some of these may not be important to add. Yeah, so also we need to define the v time, and also yeah, perfect. This one also will be why TCI plus, sorry. Yeah, it's happen when you are reading your notes and talking to you, and also implementing to some code, so these mistakes can happen. Sorry about my voice, I think I got a cold or something. And also I need to flush it. Perfect. Yeah, see, you can also see the documents here. Now we want to set the set of features that we define inside the for the file descriptor that we already opened. And we need to also give that. So if it failed to do so, we need to raise an error. And if any error happens here, the rest of the code would be obsolete, so we don't need to do it. And at the end, if that one was successful, we just simply assign the file descriptor that we just created to the dev handler that we defined to handle this, to keep this file descriptor. Okay, now let's do the end function. So again, we do the end function. We don't have anything for the as argument for this one. We just mention if is opened. You need to close it. Yes, and you need to make it -1. It's because it closes it, but it doesn't change the value of the dev handler. So if we check it, it seems that it's open. It's still open because our isOpen function actually check if the dev handler has some value more than 0 or something like that. So it's better you do that just to make sure if you close the channel, that is open, show you okay, it's not open anymore. And let's do the important thing. Of course, it has argument, and arguments were you int 8. Yeah, so as I mentioned, it's a buffer, and the size of that buffer, or I just look at it, we define it as length, so we're gonna do that. And for this one, we just simply use the read function, and we use the handler, buffer, and length as our argument for the read. Moreover, we are going to define the serial and send function. So let's do that. And for doing that, so as I mentioned, the send function receive a buffer that the data need to be transmitted to the sensor and the length of that buffer. And simply you just use write and do that. That's it. The important thing is the length is the number of bytes here, and here it would be the size of the buffer. So I'm going to make sure that I define this. Perfect. So our interface for the device file connected to that WitMotion IMU sensor is done. The next step is to implement the IMU handler, or the handler that actually provide the communication and the subscription feature that we mentioned earlier.